In this video, we are going to look at combining multiple resistors in a single circuit. Now we can do this in one of two ways. Either resistors can be combined in a single straight line, which is known as a series circuit. This is indicated as a left figure on this slide here. Or you can have your circuit branch into several different branch lines or parallel lines and then recombine later on within a circuit. This is known as a parallel circuit. That's depicted here in the right figure on your screen. Now, when you have multiple resistors in a straight line, a series circuit, we have two very important points that are that come up in a series circuit. First of all, the current through each resistor is the same. And that makes sense because when you have one line, there's only one channel for charges to go through. So it's the same current, same amount of charge flowing through these resistors. So the current is the same for each resistor in a series circuit. However, the amount of voltage that's lost going across each resistor may be different. So across resistor 1, you're going to have some voltage drop V1. Across resistor 2, you're going to have some voltage drop V2. Across resistor 3, some voltage drop V3. The total voltage drops across each individual resistor, so the total voltage drop of all the resistors should equal the battery voltage. So for example, if you have a battery that has 12 volts, then the total voltage drop across the three resistors has to also equal 12 volts. Now, we can simplify a circuit significantly by treating the circuit as if it were just one resistor. Here's how we're going to do that. Remember from the last slide that first of all, the current is the same through each circuit, but the total voltage, the terminal voltage of the voltage source, your battery, is going to equal the sum of the voltage drops across each resistor. So in other words, V equals V1 plus V2 plus V3. Well, from Ohm's law, we know that voltage is equal to current times resistance. So the terminal voltage is going to be the total current through the circuit times the total resistance, or what we call the equivalent resistance of your whole circuit. But that is going to equal the current times resistance for resistor 1 plus current times resistance for resistor 2 plus that for resistor 3. But remember that all of these currents are the same. So if I divide by I from one term, it divides I from all the other terms, and you're left with an equivalent resistance equal to the sum of all the resistances. So now, even though our circuit in this figure has 3 resistors, we can calculate the total resistance of the whole circuit as if it were just the one equivalent resistance, and we do that just merely by adding the resistances together. Now, a parallel circuit is a circuit where the current branches into 3 separate routes. Now, since the current is split through different branches, the currents are not the same. So here you have 3 different currents, one going through each resistor. However, since these 3 currents all came from the same current, then it just makes sense that the 3 currents added together have to equal the total current that you started with. Think of it as a river. You have a river of current, and it's branched into 3 different branches. You still have the same amount of water flowing, It's just that some of it flows through one branch, some flows through another branch, some through the third branch. But take all three branches together and you still have the same flow of water. How do we find the total resistance of a parallel circuit? Well, we take Ohm's law, and instead of using V equals IR, we solve for current, so I equals V over R. Now we just saw that the total current is equal to the sum of the currents through the parallel circuit, which means that the terminal voltage divided by the equivalent resistance is equal to the sum of currents through each branch. And yet each resistor is going to have a current equal to V over R. Now, one thing more to learn about a parallel circuit is that the voltage between points A and B is going to be the same across each resistor. But basically, here's what we're saying. If the voltage is 12 volts, let me clear up my screen a little bit. If your battery has a voltage of 12 volts, then the voltage drop across this entire parallel circuit has to also equal 12 volts. And since each of these are in different lines, each resistor is going to feel that same voltage drop of 12 volts. So each V in this equation here is the same. Each one represents the total voltage, the terminal voltage. And since they're the same, we can divide them out, and that tells us that 1 divided by the equivalent resistance is equal to 1 over R1 plus 1 over R2 plus 1 over R3. And of course, if you had a fourth resistor, you would just add the fourth resistor. Same if you have a fifth, so on. It just goes on and on and on.